Today's project is the making of this year's annual Christmas ornament. This year's ornament is going to be made from skeletal scraps from another project. This is 1/4-inch Baltic birch plywood left over from another project, and I have several pieces just like this. There's enough room on this piece of skeletal scrap to accommodate 7 of these ornaments. To do the project efficiently, since there are 5 different tool changes involved in the making of this ornament, we're going to cut each tool 7 times on this scrap, and we'll be doing that using the fixture features provided by Mach 3 and Fusion 360 to do that relatively efficiently. We'll be showing that process in some detail throughout this project. The skeletal material will be mounted on this piece of MDF, which is screwed down to the board of the CNC, and it has been surfaced with a 2-inch surfacing bit to make sure that it is perfectly flat in relation to the machine. I made a template of the ornament using the final contour path of the ornament that gives me the final shape of the ornament, and I located the 0 point that's used in the tool path with a hole. This will be used to locate the 7 spots on the skeletal scrap that can be used to make a proper ornament. Using that template, 7 locations were found that would accommodate the seven ornaments. The perimeters of these locations were marked with a pencil, and more importantly, a dot was placed at the origin of each to mark where the origin of that, quote, fixture would be placed. In addition to the wooden perimeter clamps holding the stock to the spoil board, several screws were strategically added to make sure where the scrap would not be held by the wooden clamp, the screws would hold the workpiece in firm contact with the spoil board. The first tool path is a 20-degree V-bit. It will be used for the letter engraving on the circumference of the ornament. The first step after mounting the tool is to home the machine using the reference all home button on Mach 3. In my particular machine, the home position is in the forward left corner with the Z at the maximum height. Now, the next step is to zero each of the 7 fixture locations. This will be done by first moving the tool to the approximate location of the first fixture. Mach 3 provides 256 different fixture locations. These are accessed on the Offsets tab and are identified as fixture 1 called G54, fixture 2 called G55, fixture 3 called G56, 4, 5, and 6, accessed here by these buttons named G54 through G59. The fixtures beyond number 7 are called G59 P7, G59, P8, and so forth up to G59, 256. To access fixtures beyond 6 on this page, and the active fixture, by the way, is shown in this window, you have to enter the fixture number that you're interested in. For example, if we're interested in fixture 7, I would enter a 7 on the keyboard, and then the active fixture is displayed here in this screen. The routine for zeroing each fixture is to select it. Here I'm selecting fixture number 1, identified as G54, which by the way is the default fixture. With that selected, I will then jog the machine manually so that it is exactly where my dot is on the stock for that particular part that I'm going to manufacture at that fixture location. And with the machine located there, I will then zero the X and Y coordinates with these two buttons. Let's do that for fixture number 1, G54. I'm now jogging the machine to manually using my handheld device. And now that our tool is pointing right at the dots, we'll now, while fixture G54 is active, as indicated here, we will zero it out on X and Y. We'll now do that for each of the 7 fixtures. I have now jogged the machine so that the tool is pointing right at my second fixture, G55. We'll now make fixture 55 the active fixture, and we will now zero it out on the offsets page. And now the third fixture is zeroed on the dot for fixture G56. We'll make that fixture active, and we will zero it out. I've now manually jogged the machine to the 7th fixture location, and in order to enter it, I need to type a 7 to activate the 7th fixture. That's indicated now by this display, G59P7, and we will now zero it out. So that now all 7 fixture locations have been located and stored in the Mach 3 system. We can call up a table by selecting the fixture selector in the general config or in the config menu, and here are all of the X, Y, Z locations for X and Y. The Z has not yet been set, but here are the X and Y locations. For the first 6, to expose the 7th, we just have to go down one more line and see the 7th location. Now, as a sanity check, we're going to double check that I did all of these zeroings correctly. We'll do that by going to the offset page and going through the fixtures one by one. I just set it for fixture number 1, G54 active. And we're going to go to 0. And we'll confirm that the machine goes to the location that I set for fixture number 1. Now, at each fixture location, as we check them, we're also going to zero out the machine. For zeroing out purposes, I've removed the tool. I'm checking to make sure I have continuity with the empty tool holder, and we're going to zero out the machine at each fixture location. Without a tool. Now we'll do that for each of the 7 fixture locations. After zeroing all 7 locations, we can do a check on how accurate our machine is doing, because each of the Z's theoretically should be the same. And here we see fixture G54 at location number 1 is within 1,000th, or is within about 2 or 3 thousandths of 55, and here 55 and 56 are very close. 57 is off by about 6 thousandths. 58 is off from the others by 4 or 5 thousandths. 59 is back down to 121, and fixture number 7, G59P7, is at 6,121. So they're within 5 thousandths of one another. Now I've reinstalled the first tool, which is the 20-degree V-bit, and we're going to make the first fixture active. It's G54, and we're going to go to that fixture location, and we're going to zero out the machine with that tool in place. Check continuity.
Starting the V program. The output is now 0.
And we'll see what that offset turned out to be, and make a record of that and compare it to what it was prior. Now, the stick out before the tool was inserted, the Z without the tool was the 6.1238. The Z with the tool was minus 5.0803. The difference between those is the actual measured stick out for the tool, 1.0435. That is now a number that we can enter as the stick out for this tool, and we can then use that to run the tool path at each of the fixtures, and it will have the proper Z height. I've loaded the tool path for the first tool, and that shows me that the tool number that is assigned to the 20-degree V-bit is T1. And we can go confirm that by checking the G43 command, which shows the use of H1, the height for tool T1. What we're going to do then is go to our Offsets tab, and we're going to enter the tool number, which is tool 1. And we're going to enter that offset or tool length that we just computed, which is 1.043. And then we want to make sure that the tool offset on off is lit. So for tool 1, we set the tool offset to be 1.043, which is the tool stick out that we have just computed. And now we're ready to run this tool path for all 7 locations. And that completes the 7th fixture location. And now all 7 fixture locations have been routed with no operator intervention required, and 7 basically random locations with just one push of the cycle start button. We now have loaded the second tool for the second tool path, which is a 30-degree V-bit. We're now going to measure its tool offset. And the tool offset for this tool is 4.7648, which will compare to the toolless reading to get the stick out. And here is the calculation for the 30-degree V-bit. The original Z height without a tool was minus 6.1238. The Z height with the tool mounted, minus 4.7648. The difference is the tool stick out, 1.3590. Now here is the tool path for that second tool, and notice that T1, confirmed by the H1 in the G43 command, is the tool number that I happen to use for this tool. So we go to the offset, tool 1. Now we're going to enter the stick out we just computed of 1.3590. And now we got that in there, and we got the green light for tool number 1, 1.35. Oh, whoop. Got a little dyslexia there. Want that to be 1.359. 1.359. 1.359. The third tool for the making of the ornament is this 1/8 inch compression bit. It's a compression bit because the bulk of the tool is a downcut tool. This area is all downcut, but at the very tip is an upcut style, so that when the tool is fully plunged and fully engaged in the work, the upper part is forcing the fibers of the wood down, and the lower part of the tool is pulling the fibers up, so that you get a nice clean cut as it goes through the part. And now, as before, in preparation for running the third tool path with the compression bit, we need to measure the stick out of the tool. The tool's been mounted. Now we're going to measure the Z in the first fixture. And the Z for the tool mounted in fixture 1 is minus 5.1597. And as before, we compute the stick out for this tool by subtracting the Z height with the tool that we just measured at 5.1597 from the Z height of the system with no tool of 6.1238, which we measured previously. And that difference is the tool stick out for this particular tool, which is 0.9641. We'll enter that tool stick out here for tool number 3, which is the tool number assigned to this tool. That's 9641. So now for tool number 3, we have 964 entered, and the tool is turned on. That's off, that's on. And here is the tool path number 3. Notice that this is tool number 3. And again, we'll confirm that in the G46 command, which is citing H3. So now we're ready to run this tool path. This tool will use a helical tool path to get down to the 1/4 full depth, and then at that full depth we'll route out all of the areas that need to be pocketed in the ornament. And there are all 7 fixture locations after the first 3 tool paths. The next tool number 4, is a 1.5 millimeter end mill, and as before, its stickout was measured and entered as the tool length for this tool path. This tool path with the 1.5 millimeter end mill will give all of the pockets a final contour finishing pass, as well as make some additional pockets that were too small to be done by the 1/8 inch bit. The 5th and final tool for this project is a down-cut 1/8 inch end mill that'll be used to contour the final outline of the ornament. A sharp chisel is used to cut the holding tabs to free the ornaments.